Welcome back to the course Make It Work React Hooks by Fang. This is the second video in the series, useState to build component.
Okay, let's continue our journey to build a Pokemon app where we want to search through a collection of Pokemons. So far we have an input box as we have built from the previous video. With this input, we can allow the user to search a list of Pokemon. Alright, before we get that, since we're start to add more and more stuff to the site, it's a good time for us to visit our current folder structure. So let me add a new folder, features. It'll be where I store a collection of files that related to the Pokemon search. Okay, so let's add a new file inside the Pokemon TSX. So I copy app to the Pokemon because the majority of the functionality will be the Pokemon.tsx. All right, I'm gonna rename the file name, the component name, and I'll keep majority of the stuff here, except I just need to delete some of the styling. All right. So I'm going to come back to the app. Since now I have the Pokemon.tsx, I'm just going to reference it. So I'm going to import it from the file that I just created. Okay, and I also missed the index file so that I can export the Pokemon from the Pokemon folder. So this is just a TypeScript, JavaScript thing so that we can import export things from a folder. Okay, since we have the Pokemon exported, now we just import it here, and I'm gonna delete the majority of stuff just because everything is coming from Pokemon now. Okay, I'm gonna give a shot. Yeah, seems it's still working. This is also a good time to delete things that we don't need. For instance, the style app.css, which get created from the default create React app, carries with some default settings that we don't need. We can delete some logos, animations, so that we can get a clean setup for our feature Pokemon. All right, come back to the file Pokemon.tsx. All right, in order to search a list of a Pokemon, we will need to have a list of Pokemon. All right, so the list will be fetched over the internet normally. And since we will introduce you how to do that in the next video, for now, we just assume that this list is already fetched and stored in a local array variable list. And this list will be look like a typical API result structure. It's an array with lots of elements, and for each element it will have ID, which is a unique number indicating this Pokemon, as well as the name of the Pokemon. And here we're just gonna quickly wrap up 8 unique ones, which we fetched from the API. For each of the item that will also have a picture associated with it, and the picture luckily is an image source which depend on ID of the Pokemon. So as long as you give me ID, let me copy the image address, and you can see it's image that as long as you give me the ID, I will return you one of the image of the Pokemon. So okay, now we have pretty much everything. Let's try to display this list using the React component. Okay, so we make a div, and inside for each of the item, we will make a key using the ID of the Pokemon, so that make each element to be unique. And inside, we're gonna list each Pokemon's name, ID, and as well as the image using the utility image function that we just made. And let's give us some caption, alternate caption for the image as well using the name. All right, cool. So that's pretty much it. That we list. You can see from the browser, each Pokemon is listed row by row. Okay, so now we want to make this list look a little bit pretty. So let's add some styles to the component. And it happens that Create React app supported a CSS module. So let's see how we can do that. Let's make a file called pokemon.module.css under the Pokemon folder. And inside, we're going to start two major elements. One is the entire list, and the other one is the list item. So for the list, we want to make it a flex layout, and it's wrappable, and we want to make a spacing to be evenly. Let's give a gap so that they don't stick together. And for the each item, it's also a flex layout. We want to make sure they are like a column based, and they can center to the screen as well. And also we make each item to be at the most 160 pixel, so that the layout can be a little bit compact, because in the end we might have 100 Pokemons in this list. All right, so since now we have the styles defined, let's just import it from the file we just created. And the nice thing about this is once the style is defined, we can utilize this as a JavaScript object. You can see styles the list is available for us, and we also have the list item that we just created, and we can wire with the class name for each of them. Okay, see, you can see from the browser, yeah, it's already working. So the font size seems like too big. Let me make it a little bit smaller, and also make them look like you can point to each of the items. And also I want to make the margin to be a little bit bigger. This way, yeah, maybe try a little bit more. So this way the input and the list don't stick together. Okay, cool. Now we have the input box and the list. So the next thing is to stitch them together to finish the search workflow. Let's add a button first to this search action. All right, let's find a space. Okay, let's make a div first and move this input in. And we're gonna make a button with onClick event, so that when it's clicked, we need to do something. And the captions go, okay. So the onClick event is when we click this button, we want to assemble a list of found Pokemons based on the user searches. And then hopefully we can set this result somewhere. So this is the best place we can think of how to use a state. And one easy way is that comes to my mind is we need a state to store the found results based on the search. So let's try what we have learned so far. Let's make a variable called results, and set results, use the useState. Okay, so let's come back to finish our algorithm. So the found is equals to the list.future. And inside, we just want to make sure if every Pokemon name matches with that value. And then we set this results. Okay, currently we have some editor issues. it says some of the type is not defined. So yeah, so when we define this list, we forgot to define the type of each Pokemon. So let's try to finish it here. The Pokemon type basically is ID, which is string, and the second one is the name, which is another string. All right, so with that defined, we can refine the list type, which is just Pokemon type, as array. All right, same thing here. So now we have a types, and we know what this state type as well, which is just basically a Pokemon array. And we initialize the array with the empty array. Okay, we forgot the array, so we go back to change that. Okay, all right, so now, so this results is something that we really want to wire with the display, because we only want to show the results, not the entire list every time. Okay, and one more thing before we go is we want to make sure the initial search value to be empty to start. Okay, let's give a shot now. Basically every Pokemon probably have an A string in it. So, and we can try another one, VN. Okay, seems like only get one of them. All right, cool. Seems like the search is working. Good job. All right, so I also want to revisit the styles here, because currently it seems like a little bit conflicting with the default styles. So let me fix that as well. Delete a couple of alignment thing which we don't need. We will definitely come back to make it even better in the future videos, but for now let me quickly change some of the lines. At least they can wrap. All right, cool. Let's also make the margin to be a little bit spaced, so that we don't start from the very top of the browser. Okay, so I guess we pretty much finished. The search is literally working. Let's do some touch up. Make some space between the input and button. Since we have used the useState hook a couple of times successfully, let's take a look at the syntax of the usage of the useState in details. It takes one input parameter initial value, which can be in any type, and it outputs an array, where the first element of the array is a state, and the second element of the array is the update function setState. Since we're using TypeScript, it's better to define the type of the state variable, such as Pokemon type array here. And it's really straightforward to use this useState hook, as we have applied them to both the value state for user input and the result state for the filtered Pokemons. What's interesting to point out for the useState is the output type, an array. You might be expecting an object, but an array has an advantage over object, where you don't need to know the element name when referencing them. For example, in the value case, we use the value and the set value, and in the result state, we use the results and the set results. These names are arbitrary, you can see, and literally you can use whatever name that fits to the business at the time of the writing. It provides quite a bit of flexibility in practice. The setState function is really worth some discussion, because this is the official way of updating the state variable. This means if you attempt to update the state variable manually using an assignment like value equals to 3, it won't bring your state variable to the next render. In order to update the state, we need to invoke the setState function and provide it with a new value. After the value is successfully updated, it will trigger a render to this component automatically for you. If you are interested in this process in a high level, you can revisit the previous video where we handcrafted a state hook from scratch. A popular question we get often asked here: does all setState call make a new render of the screen? It seems so in our Pokemon search exercise. Every time when we hit the goal, it provides us a new list of Pokemon. But this is not always the case because React wants to keep the whole app performant. So it wants to optimize in a way to avoid any unnecessary renders. The optimization is quite complex, but one of the most effective mechanisms is to check whether the state has been really changed or not. Since if it's not changed, the render is then skipped. Okay, so now you ask, how does React decide whether there is a change? This is when you invoke setState function that provided a new value by you is then compared to the old value stored from the previous render. For instance, if the new and old value is false and true, then you know they're not same, so it's going to be a valid render. And if it's 1 and the old value is 2, then we know it's a render. And same thing, if it's a string ABC and happens the old one is ABC, then we know we can skip it. And if it's none and old value is none, then once again skip. So you can see it basically determined by the comparison between the old and the new value. Quite straightforward. However, there's a catch. Since there is another type of JavaScript variables that doesn't fit into the above scenario, and they are called a non-primitive data type, including object and array. For these types, the comparison carries a twist. For instance, let's say we have object, empty object. All right, so if I compare the object with itself, you can see they always equals to each other. So it's a skip to the render. All right, so this is one of the interesting things here. So if you compare it to itself, it will always be a skip. All right, so what does that mean? So suppose I add attribute to the object. Let's say object.name equals to font. All right, and we know the object changes. But if you still compare the object to itself, in the, let's say, next dispatch, you change the object and you want to check the old and the new value of the object, you see they're still equal to each other. So from the React perspective, it's always going to be a skip for this render. All right. So say now we have two objects, object 1 empty, object 2 empty. They both look identical in content. But if you compare object 1 with object 2, they do not equal to each other. So it's going to be a new render. So this is also interesting here because no matter how the content is identical between two different objects, as long as there are two different objects pointing to two different memory spaces, they were never equal to each other from the comparison. So to React, it's always going to be a render, a new render. All right, so I just mentioned that there's a non-primitive type, and object is one of them. So another one is array. So let's take a look at how array behaves. Say we have array which is empty, and if we compare it to itself, it's going to be a skip because they didn't change. All right, it's a similar behavior as the object. But if we push something to the array, let's say the array is expanding, it changes, right? But afterwards, if we compare the array to what we think is a new array, but it's still pointing to itself. So if we check array equals to array, they still be same. So to React, it's going to be a skip. So no matter what you do, even you think it's changed, it will never render the screen again. All right, if we have two array 1 equals to empty, array 2 equals to empty, and make a guess now, the array 1 is still not equal to array 2, even though they are both empty arrays. So to react, it will be a new render. All right, cool. So I hope this demonstration makes some sense. And if you are relatively new to the JavaScript comparison, I suggest you to watch this a couple of times, or even pause this video to practice a bit yourself. And essentially, when it comes to the object and array, the value it uses to compare is the reference instead of value itself. Just keep that in mind. If we come back to our set result state case, with the knowledge that we have learned, we can check we are operating in Pokemon type array. It's a non-primitive data type. We know in order to trigger a new render of the screen, we have to make sure the found array is a new array pointing to different memory space than the previous render. In case you haven't noticed the list filter call, it actually always filters an array and returns a new array. Therefore, it actually serves our purpose here. See, if we type different character in the input box and hit a go, every time we should get a different render. Cool. But in case you want to suppress a render, this is also the place where you want to apply it. We will introduce this type of optimization in future video when we introduce a new hook. Alright, I will stop here for this video of useState hook. I hope you enjoyed watching this video, and I'll see you in the next video where we'll introduce another React building hook, useEffect. Thanks for watching.